Gracias. Buenos dias. So we have heard some really interesting talks so far today that reinforce my sense that we're in a very exciting time, that machine learning and AI have moved from the lab into the real world. I'm going to be talking about InterSystems, what we're doing in this domain, what our customers and partners are doing, and the theme is to accelerate this movement and accelerate AI. And really, there's two parts of this. The first is for the people that are building AI systems to make it easier and faster. Who in this room, even way back there, is a developer or building applications? Okay, you can admit it. It's actually not, it's cool to develop things. But the other part is to incorporate AI where you don't necessarily need to build something. You may hook together very smart processes and apply them in your organization. So I'll be talking about both of these. And Jordi, earlier today, gave you a very quick sense of who is an InterSystems and our product. InterSystems Iris is a data platform. So we're coming at this from the perspective of data being the new driver of the economy, and data being the fuel for machine learning. That's what brought InterSystems into this arena. And InterSystems Iris, and we have a Iris for Health product because we do a lot of work with healthcare systems all around the globe, are a single product that includes a very fast multi-model database. And that can work as a data lake. It can work as a data ingestion point and work in any model. It also includes a built-in analytics or interoperability component. Is anyone here using a product called Ensemble? Yes, a few of you. Thank you. So this is something that connects together existing systems to make more and more effective use of your data, usually throughout an enterprise, but often between companies as well. We have also built in analytics, and that's the focus today because I regard AI and machine learning as related to analytics in this sense. And then specifically for healthcare, we have a very comprehensive set of protocols. If you're not from healthcare, this will be gobbledygook, HL7, DICOM, X12, FHIR. But if you work in healthcare, it's a very exciting time because a set of standards for really talking about medicine and health are taking hold. In addition to what I'll really be talking about, which is development technologies and data management, InterSystems provides products largely in healthcare. One is which is called Health Share, that builds on this technology to create a unified record of someone's health. In the States, it's often across state boundaries or across different healthcare systems. Same in countries like the Netherlands or Holland, where healthcare is localized. We also provide a system which is an electronic health record system called TrackCare. So everything I will be talking about is in the context of Iris, but we use InterSystems Iris and TrackCare together, in many cases, to take clinical data and then make use of it. So clinical data residing in TrackCare plus other data combined for new insight or more intelligence. Okay, so that's a sense of the frame, if you will. I have set themes as I'm responsible for product direction. Where are we investing at InterSystems in new areas? And there are 4 themes. Speed and scale, freedom of choice, which is the ability to connect together multiple systems and work in the language of your choice or the tools of your choice. Cloud, and AI and machine learning. And today, really just talking about how InterSystems accelerates AI with some examples. So who in the audience has already done machine learning? Okay, and who is here to learn something about it? This is not, I did not plan a deep tutorial, although there are some good materials on it in lots of places, including the InterSystems website on what is machine learning, how does it really work. But you can think of the programming you are used to as taking data and instructions together and coming up with an output. And in a very oversimplified way, machine learning, which is a subset of AI, is doing the reverse. It's taking output examples and input data and generating a program. So there's classes of algorithms, things like random forests, or you've heard a lot about deep neural nets. But the actual parameters of these algorithms are what makes the program. And has anyone used a Jupyter notebook? Great. These are a wonderful thing for data scientists and non-programmers. It's a very accessible way to build a project. Again, if you're interested in knowing more, there is a 40-minute course on use of the Spark connector on the InterSystems website. With online, hands-on stuff, but that's a typical environment for a data scientist. Often it's not connected with the real world. It's hard to connect it to the real data. It's hard to connect it to the real systems. And part of it is that the work of data science, of creating this program, these out from the data, is a very small part of the overall process. I mean, you hear different statistics, but typically about 80% of a data scientist's time is spent on wrangling the data. And the joke is that the other 20% is spent complaining about wrangling the data. There is a lot that comes into acquiring and preparing the data. And as I said, this is what got InterSystems into this arena, because we do data for lunch and breakfast and dinner. But there's also an interesting set of problems that comes in deploying models, because these systems behave differently than people are used to in IT. You don't want your best people away when you first deploy them, because they'll learn as they're going. So it's everything from the way you staff to the way you think about operating things is a little bit different. Now, I said I'd be talking both about accelerating AI and incorporating AI. For accelerating AI, InterSystems as a software company focuses on building for builders. So of the stages that I talked about, the wrangling the data, the creating the model, and deploying the model, our focus across these is to make wrangling much simpler, to make creating the models faster, and to make deploying the models fast and safe. And I'll show you a bit of how we do that. One important tool that, frankly, we have had in production at many customers for 10 years is a facility for taking predictive model markup language models and working with them in production at very high speed and low latency. So real-time decisions can be made off of these models. And this is a standard way of taking models. Many of these models were simply called predictive analytics until machine learning became sexy. You just changed the name. But many of them are newly useful because of the availability of data. And this is an example from one of our partners that has applied this approach to an electrical grid. In this case, there's a little bit of a movie on it. There's data coming in from sensors from about 10 to the 5th, or 12,000 different electrical transformers spread around a grid. They're different types of transformers of different ages working in different temperature areas. And it's important to see when they stop working so well, especially because when they really stop, they can explode and they kill people. So you can imagine that getting better predictions of the maintenance of these transformers is a big deal. The way this was implemented involved routing the data. This is an example of the InterSystems interoperability routing. So this may be hard to read, but we're taking in transformer signals and sending them to multiple services that both do the modeling and also do the reaction. The model itself, in this case, was not complicated. It's a random forest. But applying the model based upon vibration, temperature, oil levels, not that many types of data, involved generating a decision about what you do. What is a safe threshold? And then sending to their CRM system, their maintenance system, alerts so that an operator could say, oh, I'm going to actually deal with this problem and replace things at threat level 1. And they particularly use the ability to go in and trace. That's one of the areas many of our customers say they love about InterSystems interoperability, is that you can trace through, go back, see what happened, use it for auditing. So we have had the PMML import for quite some time. About a year ago, we added a Spark connector. And if you're not familiar with Apache Spark, it's an open source framework that in many ways has taken over from Hadoop because it actually performs. And it is a favorite environment for data scientists. As part of our data platform, where we focus very much on scale and performance, we've made a parallel Spark connector so that this large amount of data used for machine learning can be worked on at high performance. And then the data scientists work in an environment that they're familiar with their favorite tools, but have access to the data from production systems and can create and deploy these PMML models. So for customers and partners of InterSystems that already have a strong data science team, this has been a very good facility. This is an application built with this for law enforcement. I live in Boston in the States, And I like to think it's a very safe city, but in fact, crime reports mixed with real-time reports from citizens is a very powerful way to focus law enforcement. And it is not real-time in terms of seconds, but it's definitely real-time in terms of minutes. And this uses InterSystems Iris in order to capture all of these signals, supply them, and then, of course, audit them. And the Spark connector adds performance. It also adds isolation. Here's another example. From the States, we work with many very large health organizations. This is Partners Health, which operates, I think, 15 hospitals, including one called Mass General Hospital. They have what's now a 7.5 petabyte database of biometric device information. Every pump, every blood measurement, in every bed, everywhere in their hospital chain is captured. And the data scientists at Partners have been wanting to get at this data for over 2 years. They go to IT and say, just give me a copy. Just give me a CSV, an Excel file. That's the famous, that's what everyone likes. And IT goes, no way. This is huge. It's petabytes of data. It's full of private information, and you will gum up my network, leak private information. No. And therefore, for 2 years, Partners was accumulating more and more data that was effectively write-only data. They got no use of it, despite having a great data science team. They took 2 steps. The first was to move this database to the cloud where they could get computing power to really apply to it. And the second was, by using this Spark connector, they could apply database permissions, use materialized views so that the data scientists could only see things they were allowed to see, that all private data was masked, that nobody could export the data and take it home. So they broke the impasse between IT and data science with a very simple technique called security. So this just gives you, this is not deep learning. This is the real world where security, privacy, locality concerns of data interfere with the ability to do exciting machine learning. The third challenge that we see a lot, InterSystems has tens of thousands of customers, many of whom are developing their own applications. And when we went around with our parallel Spark connector working in TensorFlow and Keras, most of them were like, I have too much to learn. I can't hire people. Perhaps I will use send people to school. But the staffing for ML and the learning curve is a big issue. And therefore, we focused on applying what is called auto ML. It's machine learning on machine learning. Taking the elements that take the most labor from data scientists, remember the 80%, and squishing that down. Some of it is deciding what part of the data to use as features. Turns out you can apply multiple machine learning things at the same time in parallel if you throw enough computers at it and see what works and determine how to automate machine learning. So by collapsing the middle of this process using AutoML, we believe that we can put machine learning in the hands of people that aren't experts with machine learning. They have to be experts with their data. But we are introducing a new facility called Integrated ML, again, built into our InterSystems Iris to make it easy for a SQL developer. How many people here use SQL? Okay, so there's more people raise their hand saying that they use SQL than raise their hand saying they were developers. SQL is very common and it's very familiar to people who work with data all day. So we have introduced 3 simple keywords in the SQL syntax. One is creating a model. So to create a model in Integrated ML, you do not go into a Jupyter notebook. You don't go into TensorFlow. You simply pull up your favorite SQL editor, dbeaver, and type this. And then you've created a model. You can train the model based upon the data that is there already in your application. And if you need data that you don't have, you're sitting in a database with an integration level layer built in, so that the work of collecting the data and normalizing it is not gone, but much easier. And that's a train model. And then you can select predict. So if you're familiar with SQL, select is like the universal keyword for what you often do. And you can use these predictions then in any way that you could with SQL. You can sample on them, use the top 10, use joins, materialized views with these predictions. And the early customers for this are very excited about, one of them told me, I'm taking an application that has only looked backwards, has only looked at history, and I've added the ability to look forwards through these predictions. It's pretty cool. So I talked about the model, and really you need to know your data enough to know what kind of things you want to predict. So the health of a power transformer obviously is something you want to predict. Often that is a column or a couple of columns in a database table. The training run involves source data, and we're building multiple what we call AutoML providers, both one built in and the ability to work with some of the best in the industry, such as DataRobot. And then with the trained model, you don't need to worry about deploying it. AutoML, it's already there. And many of these AutoML providers do what is called ML ops. They give you a sense of whether the data you're getting is different than what you trained on, and if the model is what is called drifting, and give you operational statistics for how your system is running. So that's called integrated ML. If anyone is interested in using integrated ML, we have just started a private beta this week. Just scan this barcode and you'll get signed up to work directly with it. We're very interested in getting feedback, specifically about the ease of use for people who are not expert data scientists. Now, I won't say that you can forget about data scientists, but you can bring them in as experts later in the cycle. You can optimize the model after you've done 80% of the work, and they'll be much happier, and you'll get to value much faster. I'm going to speed up and talk about a couple of other things so that you have a sense of the breadth of what InterSystems is doing. The first is about data quality, because all data is dirty, and most data just sucks. And what I talked about with integrated ML doesn't really solve the problem of data quality. It automates data wrangling and makes it easier. And I could write, actually, help write a book about data quality, so you don't want to listen to me for that long. But we have a module called Health Insight that takes healthcare data from multiple providers. The average in the US, the average Medicare patient has 9 providers in 7 different networks, so we're very, very fragmented. And then by comparing this data, which is often duplicate, sort of, you can triangulate and end up with better quality data. And we have a number of partners that are using this as a data source for healthcare in particular, using the same thing I just talked about, the Spark connector, importing a PMML model, and having a data science cluster that might be in the cloud, might be on-prem, working within their system. One of them is based in California. It's a company called HBI. And they work with data, both clinical and financial, to do custom machine learning, really fit models. Often these are different for each hospital, and provide risk scores. They're using everything I talked about. They're also using a natural language processing capability that we've built into InterSystems Iris called iKnow. And part of what's special about this is it looks at language and finds things like measures or certainty. Or even negation. This is breast cancer, this is not breast cancer. There's a big difference between those. This is probably breast cancer. This is almost definitely not. So these kind of language that is found in every industry. We see this in financial services, in insurance claims. We see it in claims notes in the medical domain all the time. HBI uses this. And by the way, if you are either a developer or a development shop, as of last week, we've made this technology open source because we've determined that people who are using this, often we support 11 languages, but there's people in China that want to build their own Chinese models. And there are people that want specific language. The drug companies want causal language to determine that, not just that a disease and a treatment have a statistical co-occurrence, but looking through the literature for things that imply causation. So we can get more done by open sourcing it. Back to HBI, they've now applied this still in healthcare or in healthcare finance to quite a variety of problems. But there's a classic problem of readmission, not letting people out of the hospital if they're likely to come back. There's a length of stay issue, and often these are in the States, and many countries have financial penalties for keeping people in the hospital too long. And this has grown from when they started with us, which is almost 10 years ago now, when we were calling these predictions statistical analysis, to using much more sophisticated algorithms and using deep learning and applying now at over 20 million patients, going on 100 million. So very successful in a lot of different domains. Part of what makes it successful is this toolkit from InterSystems and also higher quality data, because garbage in, garbage out does not go away just because the algorithms are fancier. All right. So we've taken this idea and announced something that goes to the next level, because many of our customers, again, specifically in healthcare, but also other domains, don't want to do very hard, dull, boring work in improving their data quality. So we now offer a service that's called Clean Data as a Solution, that uses a lot of the techniques within our products, this aggregation, but also terminology services to look at diagnosis codes, et cetera, et cetera. There's actually a 12-step process. We have a customer in the States called Concerto Health AI that's using this for optimizing healthcare in distributed settings. People who go to a clinic and should be following up on their care, people who don't take their meds, et cetera, and then want to apply this to drug development and design. So I've talked mostly to this point about accelerating AI, about what we've built into our products at InterSystems to make it easier for people who are building stuff, like HBI. I'm going to switch gears and talk about incorporating AI, where you can do a lot with this technology without building models, either by what I'll call choreography, stitching together different services, or by simply surfacing things within an application. So if you remember what I showed you from the transformer example, where it's a simple routing of messages from devices to systems, this is called intelligent integration, because obviously we don't make any dumb products, they have to be intelligent. And we have a marketing group that wants to emphasize that. But this is capable of doing message-based integration. We have added API management, API-based integration. We've added device integration so that you can connect together things that are very heterogeneous. And it turns out that there are 5 companies on the planet, each spending more than $4 billion a year developing AI services meant to be stitched together. So if you use cloud-based or in-house ML services, you can connect together things and very rapidly build cool solutions. This is a favorite when we go to hackathons. Developers actually do that before they write any code. So this is an example from the oil and gas industry where they were going to different facilities. They might be offshore wells, they might be repair facilities, and taking photos and notes of everything they saw. And on average, all the field technicians were given these tablets. It's very fancy, and they took 200 photos on average at every site they went to, and they never used them, because the photos went into a giant hard drive in the sky and were impossible to dig through. So by pretty simply using Cloud Vision API, and it turns out that now Google, Amazon, and Microsoft all have custom vision services. So they're very good at distinguishing puppies on green lawns or consumer elements, where they've trained them with millions of examples. But even with 1,000 examples of oil derricks, they can do what's called extension learning to recognize things that you might not have tagged in on your iPhone. Face recognition, landmarks, optical character recognition is very high accuracy and really easy. Took that, looked at used a custom search API, because a lot of this was really around weather conditions and what is the temperature, and can I determine what else happened that was associated with this. And then all the photos were tagged, and they had a usable photo repository. They then applied TensorFlow, which is an open source machine learning toolkit, to supplement their predictive maintenance. So no models built, just models called. And this pattern is very powerful. Again, if you want to get hands-on, there is an example at what's called InterSystems Learning Labs, that does exactly this for a pharmaceutical receipt. Go to the, we call them drugstores in the States. And you take a receipt, extract the text by using the Microsoft computer vision service, and can immediately work with it. I'd actually like my expense reports done this way. Then use a Spark ML service to determine anomalies, finding things that are unusual, actually did involve building a model. And then looking for interactions between drugs for that patient and providing a quick alert to say these are compatible or not. In this case, again, you can go through this yourself in about an hour and then grow from there. And this is essentially what it looks like. Talks through the anomaly detection is one of the most interesting parts of the modeling. The last thing I'll talk about is surfacing predictions within applications and using them within our own products. So you can imagine, since we help our customers run some of the largest data repositories on the planet, and they spend a lot of time doing maintenance, that we would be working on applying machine learning to reduce the maintenance, the routine maintenance. So we are. But we have within this same HealthShare product that looks at deduplicating data, something called the patient index. And what this does, turns out, if you go to the hospital, your name may be spelled differently. I'm Jeff Fried, but my badge says Jeffrey Fried. And you want to make sure you have the right person. So the way that InterSystems has been doing this, which is the way that pretty much everybody on the planet does this same deduplication, is to have a set of rules based upon, well, if your address is the same and you just spell your name differently, it's probably the same person. And you create a score out of these different things, and then you have a threshold on that score to say, very high score, it's the same person, very low score, not the same person. And what do you do in the middle? What you do in the middle is you throw people at it. And there's a human review process used for what we call our patient linking algorithm. And that's expensive and boring. So the idea is, well, can we use machine learning to make that better? And we did exactly this experiment. And it turned out that the separation between positive and negative, if you look here, you can see that these are true links, these are true non-links, and they're overlapped. Where there's overlap, you need a person. Here, there's really not much overlap at all. Why? Because these rules were coded by a programmer going, I'm going to look at this, this, this. These rules were made by machines saying, I'm going to try all kinds of algorithms to look for how these data differ from these data and come up with the best ones. And this separation was really remarkable. Now the next question is, from a business standpoint, or in this case, what's good enough separation? And this is a thing that you do need to think about with these algorithms that you probably should have been thinking about with deterministic programs all along. But nothing is perfect. And there's a standard for specificity, which means when you say it's the same person, you really want it to be the same person. You'd rather have what are called false negatives than false positives. So applying those standards, we're able to cut the work list at a real healthcare hospital facility in half. And this looks like it's holding up across multiple sites to do what's actually better matching than something we'd spent years developing as a rules-based algorithms. Okay, so just to summarize, InterSystems is focused on managing data. And one of the side effects of that is using that data for machine learning and AI is the name of the game. You don't have data, you don't have machine learning. You got lousy data, you got lousy results. And we've built into our products a set of facilities, starting with the PMML model import, growing to facilities for expert machine learning shops. And these are mostly people like HBI, people that have a dozen data scientists on staff. But then extending it with integrated ML to places that don't have a lot of experts on staff. We've also taken this data quality conundrum and decided that we will do the dirty work. We've discovered that our interoperability, which grew up by connecting multiple systems, and many of you that raised your hands are using them to, for example, use HL7 between different departments, is also remarkably good for orchestrating AI services. And the AI services from the likes of Microsoft, Amazon, Google, now Apple, are all remarkably good and very useful. I haven't mentioned AI Toolkit, but there's a hands-on session at the end of the day for those that want to stay and really program. So this is an open source toolkit that works on InterSystems Iris that allows you to do machine learning. I can't not talk about these other areas, but just very briefly, in the cloud, we are also quite active. And these go somewhat hand in hand because you need a lot of hardware resources and compute to work in the cloud, to do machine learning. So we are available through the marketplace directly on Amazon, Microsoft, Google. We work on now many of the top cloud platforms in the world. We just added Tencent in China. We have off of our website, intersystems.com/try, a free sandbox that in 3 clicks gives you an instance running at no charge, and you're off and going hands-on. And we've been investing a lot in sort of this DevOps area of using containers and what's called Kubernetes, which is a container orchestrator. And surprisingly, we have a huge amount of downloads from something called the Docker Hub. So you will find yourself in this domain getting pulled into terms like pipelines because these get to be quite large scale in order to do real world problems on machine learning. Our traditional strength, which really have to do with high speed, multi-model databases that you can run in a distributed fashion, we are getting better all the time. So at every release, more performance depth, more configuration options. I hope we're not making it too complicated. But the idea of making these available as a single package so that if you want to take a bunch of products and put them together, you can, but you don't need to, has been working for InterSystems and working for our customers. And in general, I hope I've given you a sense for our vision in technology, what we're doing in this area to both accelerate AI and incorporate it. As Jordi shared with you earlier, I'm a newcomer to InterSystems. I've only been with the company a little north of 2 years. Many people have been with the company 20, 30 years. I've met customers in Barcelona that have been working with us for 35 years. And we're very committed to partnering with customers and distributors, OEMs, for our joint success. So if you want to learn more, there's more today. There's more on our website. Share your ideas and go build really interesting things. Thank you very much.